isn't it? On the first one, we just distribute. So we're going to distribute here. So we're going to get 6x cubed y to the 5th minus 8x to the 5th y to the 3rd. Did I do it right? Okay, excellent. All right, what happens when I multiply a binomial times itself, except the only thing that changes is the sign?
The
outside and the
bottom.
Yeah. We're going to have some canceling going on, aren't we? The negative 10x and the positive 10x are going to cancel. Anytime, what did we call this when we were simplifying complex numbers? We multiplied by the conjugate, didn't we? Because that made the imaginary part go away. Well, the same thing happens here. So we're just left with the 4x squared and the minus 25, right? Because the positive 10x and negative 10x cancel. All right, and then this one, we talked about the shortcut for this. We can square the first term, double the product of the two, and square the last term. So if we square the first term, we get 16x squared. When we double the product of the two is negative 4x. When we double that, we get negative 8x. Square the last one, negative 1 squared, is positive 1. So we squared the first, we doubled the product, we squared the last. Okay, so we've done these before. And this kind of leads into what we're going to talk about today. So today what we're going to do is factoring quadratics. And before you start writing, let's talk about this for a second. So what we're going to do is we're going to take expressions that we start with, and we're going to rewrite them as a product of their factors. I should have said product in there. As a product of their factors. All right, now you can start writing. Okay, so the first thing we're going to look at when we start factoring is we're going to try to take these expressions and rewrite them as a product of their factors. Do y'all remember way back in, I know at least 6th grade, you started talking about something called a greatest common factor. So when we talked about a greatest common factor, at that point we were just looking at what is the largest number that is a factor of these two numbers. What's the biggest number that will divide into both of these? So if we have this expression, 2x squared minus 8x, what is the largest number that will divide into 2x and 8? 2. But now we're going to throw in the variables with it, which we didn't have in 6th grade when we looked at this. So we have an x squared and an x. X. That is the largest factor that will divide into both of those terms. Well, when I take the 2x squared and I take a factor of 2x out, I'm basically dividing it out, aren't I? So if I divide that out, what am I left with? I'm just left with x. And if I take the factor out of the negative 8x, I'm just left with minus 4. So now we have completely factored the expression 2x squared minus 8x by taking the common factor of 2x and factoring it out. And we wrote it as a product of its factors. It's a product of 2x and x minus 4. Make sense? It is completely factored now. All right, so here we have another one. Here's our expression, 20ab squared minus 32a cubed b plus 12ab. negative 32, and 12. What's a common factor for those numbers? 4 is the greatest common factor. It is the largest number that divides into all those. Now look at your variables. Every single one of them has an A and a B, right? What factor of A can I divide out? Just A. What factor of B can I divide out? Just B. So the greatest common factor of this expression is 4AB. And so if I factor that out of 20AB squared, what am I left with? 5B. When I factor it out of negative 32A cubed B, what am I left with? Good. And what is the final term? 3B. Good. Any questions? All right. That's always our first step. When we look at an expression and we're trying to factor it completely, what we look for first every time is to see if the terms in our expression have a common factor. And if we do, we factor that out. And then there's some other things we look for. So today we're going to look at two of the special cases, a difference of squares and a perfect square trinomial. So a difference of squares is when we literally have a difference of two squares. So if you have a binomial and it's a difference and your two terms are both perfect squares, then we can factor it this way. So if we start off with a squared minus b squared, it'll factor to the sum and the difference of those things that are being squared. So the sum of a plus b and the difference b. And let's go back and look at our warm-up real quick as soon as everyone writes this down. I'm going to go back and take a look at that second problem on the warm-up. Do you see if I looked at my answer and I worked backwards? Is this the perfect square? Yeah. Is this a perfect square?
Definitely.
Is that a difference?
Yeah.
Do you see how it could be factored to 2x plus 5 times 2x minus 5?
Yes.
Yeah, we just went the other way with it just a second ago. Okay, so let's take a look at this one. X squared minus 16. Is x squared a perfect square? Sure. X is being squared. Is 16 a perfect square? Yeah. 4 is being squared. And it is a difference. So it is a difference of squares. So it would factor to the square root plus the square root and the square root minus the square root. X plus 4 times x minus 4. How can we check our work to see if we were correct? Boil it back or distribute it back? Yeah. And then we should get what we started with, and it checks. Okay. 9n squared. Is that a perfect square? What's being squared here? 3n. All right. Is 25n squared a perfect square? Yes. What's being squared here? 5n. Is it a difference?
Yes.
Yes. So when we have a difference of squares, it can factor to the square root plus the square root times the square root minus the square root. And if I check it, 9n squared minus 15 plus 15n minus 25n squared, it checks. Okay. Is a to the 4th a perfect square? Yeah, because a squared is being squared, isn't it? Is 81 a perfect square?
Certainly.
Yeah. All right, you guys factor that one. I'm boring Drew today. Catch up, Miss Wilkie. Okay. So we got a squared plus 9 times a squared minus 9. Is that what y'all got?
Yeah.
Why am I not done? Why is it not completely factored? Because this is also a difference of squares. So I'm not completely factored. I'm on my way there, but I'm done. Because that a squared minus 9 will factor to what? A plus 3 and a minus 3. Now I am completely factored over the set of integers. And right now, that's what we're going to be doing. We're going to factor a set of integers. Later on, we're going to do factoring where we might have other things in our answers like I, or square root of 2, or fun things like that. Okay?
Wait, so is the final answer just a plus 3?
This is the final answer right here. The final answer is all of it. That's a good question, Drew. That is the final answer.
How come you don't like do the plus 3 thing to the first one?
Well, because this is a perfect square and this is a perfect square, but is that a difference?
No.
No. So it will not factor that way.
Okay, so you only do it if it's a perfect square and
And a difference. Okay. The last one we're going to look at today are perfect square trinomials. These we've studied also. When we looked at them like this, we were like, ooh, square the first one, double the product, square the last one. So now we're going to start with this part, a squared plus 2ab plus b squared, and we're going to factor it into a binomial squared, either the sum or the difference. And the sign right here is going to let us know what we're looking at. If it's a sum here, it's a sum here. If it's a difference here, it's a difference here. And we can always check our answer by expanding the binomial back out. Okay, some of you have awesome parents and they're sneaky and they've probably already taught you how to do some of this stuff. Who's already seen some of this stuff? Okay. Yeah, good. I knew it. It's okay. I can be sneaky like that with my children sometimes too. All right, so let's look at the first example. X squared plus 8x plus 16 is a perfect square trinomial, and this is how we know. Is the first term a perfect square? Yes. Is the last term a perfect square? Okay, so the way we test it at this point is we say, okay, what did I square to get x squared? X. What did I square to get 16? 4. And if I double the product, because this is plus, this would have to be plus. If I double this product, do I get the 8x? Yes. That's how I know. This is my check step. Because tomorrow, I'm going to do one that looks like it's a perfect square trinomial, but it's not. It'll have a perfect square here, and it'll have a perfect square there, but this middle term will keep it from being a perfect square trinomial. We'll talk about what to do with that tomorrow. So we're always going to check, if I double this product, do I get the middle term? Yes, we do. So that is a perfect square trinomial. Therefore, we can factor it as this binomial square. Okay, let's look at the second one. Is 16x squared a perfect square? Yeah. Is y squared a perfect square? Yes. So let's try it. Let's see if we can factor it as a binomial square. What is the square root of 16x squared? 4x. 4x. What is the square root of 9y squared? 3y. What would the sign be here?
That's a minus.
Minus, because this is negative. All right. If I double this product here, if I double that product, do I get that middle term?
Yep.
Yes. Then I factored it correctly. Okay. Now, this one is a perfect square trinomial that's missing the middle term. What are the possibilities for the middle term?
10x.
10x and negative 10x. Excellent. Very good. So you go, all right, The square root of 25 is 5. If I double that, it would be 10x, or negative 10x. All right, so this is a perfect square trinomial that's missing the last term. What would it be? 36. What did I double right here? 6. I square it here. 36. There's only one possibility here. This can only be positive 36. Because when we square a number, whether it starts off positive or it starts off negative, when we square it, what happens? It becomes positive. All right. I want you to open up your workbook to page 329. And I want you to try 1 through 4 and 6 through 10 on that page.